Start হয়েছে তো? Meeting has started. Right. ঠিক আছে, thank you. Good morning, everyone. This is a session of first session of day 3. In this session, we have with us Professor S. Chakraborty. Chakraborty is a professor of electrical engineering department, IIT Kanpur. On behalf of organizing committee, let me welcome you in the department in the faculty development program FDPII 2020, organized by E department and NIT Durgapur and sponsored by AICT Atal Training and Learning Academy. Professor Chakraborty did his BE in electrical engineering from NIT Durgapur in the year 1997, ME from electrical department Jadavpur University in the year 2000, and he did his PhD electrical engineering from electrical engineering department Memorial University of Newfoundland, Canada in the year 2006. His research interest in smart grid power system dynamics and stability, application of synchronized measurement technology to power system state estimation, and power system stability. He's a professor since November 2018. So before joining this institute, he was attached with Department of Atomic Energy, University of Cyprus, Queensland University of Technology, Brisbane, Australia. So he has published numerous paper and publications, debuted international conference and journals like IEEE Transactional Power Systems, IEEE Transactional Power Delivery, IET Generation Transmission Distribution, Electrical Power Components and System, IEEE Transaction on Instrumentation and Measurement, IEEE Intelligent System, Electrical Power System Research, Expert System with Applications, IEEE Transaction on Smart Grid, IEEE Systems Journal, Electrical Power Components and Systems. He has completed more than 40 number of sponsored project as PI and co-PI. With this few words, I would request Professor Chakraborty to share his screen and share his expertise with all of us. Thank you, sir.
Thank you very much for the elaborate introduction.
तो इतना ही दिखता है ना, मैं थोड़ा क्या कैमरा को झुक के अंदर पॉसिबल नहीं है.
Sir, I am making you as an attendee, sir. Just 1 minute.
Okay.
Sir, you have entered as S. Chakraborty or any other name?
Saikat Chakraborty.
Saikat Chakraborty.
Oh, I think the name is showing as Indian Institute of Technology.
Yes. Sir, you rename it, sir, kindly. You rename the.
How do I rename?
Yes. S. Chakraborty, IIT Kanpur.
Yes. So how do I share my presentation?
Just 1 minute, sir.
I think I need a permission.
Yes, I need. I am giving, sir.
So this talk is till 11:30, is it?
Right, right.
Okay.
I've given permission to you as a presenter, right?
All right. So now I think I have the access. So is everybody able to see the slide now?
Yes, right, right. It is visible, sir.
Okay, okay. All right, so let's start. Very good morning to all of you. So let's put this into presentation mode. Okay. So this talk is, well, you may not directly find any innovation or any intelligence here, but this is a platform where we can test and validate your innovative and intelligent algorithms, okay, especially in smart distribution systems. So in IIT Kanpur, we developed a smart distribution system prototype. This was a project jointly funded by the Ministry of Power, Government of India, and IIT Kanpur. In the context of India's journey in smart grid, this particular project is actually uh, somewhat important in the sense that this was one of the 14 smart city pilot projects that was sanctioned by the Ministry of Power in 2014. And you see the locations here. These were the initially sanctioned projects. So out of these 14 projects, only 12 actually reached execution stage. Two were dropped for various reasons. Okay. Now, if you notice, uh, other than IITK, all other projects were executed by utilities. Okay, so we were the only academic institute uh, which was executing this project. The idea was to, especially for IIT Kanpur, the idea was to develop a platform, rather a research and development platform where we can test various technologies, smart city technologies, focusing on the electrical part only. When you talk about smart city, many things come into picture, but we are focusing on the electrical part. Okay. And this project was equally funded by the Ministry of Power and IITK, as I mentioned. And to be very specific, we looked into again the electrical aspect only, because many things may come into picture when you talk about smart city. You can smart buildings, smart roads, smart traffic system. Okay, so our scope was limited to the electrical aspects of a smart city. Okay. And a little bit about the project, overall scope and highlights. The IIT Kanpur campus was chosen as the installation site, and we have a pretty big campus. Durgapur campus is also very nice, and I spent 4 years there, and it's always good to be back to Durgapur somehow, whether it's in online mode or physical. It's unfortunate that I could not physically go there. So Kanpur campus is around 1,000 acres. We have around 4 kilometer square area, and approximately 10,000 people live there. Of course, the population is continuously increasing. This data is a little bit old. Now I think we have close to 12,000 population inside the campus. And the idea was to set up a state-of-the-art facility in the context of smart distribution system. And the one thing that we kept in mind is the typical Indian market and consumer behavior. We did not do anything which was very alien to the Indian environment. Okay, Some of the technologies, they might work very well in maybe in North America or Europe, which may not work that well, or which may not be available in India. So those things we did not try. We had gone for the technologies which are available in the Indian market, or which was available in the Indian market at that point of time. Okay. So this was very much in the Indian context. Okay. By the way, if you have any question, please interrupt me anytime. I'd like to have interactive sessions. All right. You can raise your hand, or you can speak. Okay. So feel free to ask questions. The basic idea was to identify the key challenges in smart city deployment, and what are the innovations possible in overcoming those challenges. Okay.
Hello.
And this test bed is acting as a demonstration or testing platform for academicians all over India, and also for utilities. We have MOU with Ministry of Power. Twice a year we comes for utility engineers, and we give them hands-on training on these smart city setup. Okay. So this is the purpose, is to have to conduct research and development activities, as well as to train manpower, both from academics and from utilities. So this is the overall objective of this project. The basic functionalities is they're complete now. We are going through some fine-tuning process now. I hope I'm audible to all of you. Please let me know if in case there is an issue. Okay.
Yes, sir. You are audible.
Yes, audio.
Now a little bit about this project. We had 4 major components. We had SCADA, Supervisory Control and Data Acquisition System. We had advanced metering infrastructure, including the smart meters, the associated communication and storage, data storage infrastructure. We had gone for home automation system, and as well as we had rooftop solar PV systems installed in some of the chosen houses. In fact, we chose 20 houses. In fact, 19. One is our control center. So we have solar PV, rooftop solar PV on top of those installations. But that's only a small part of the total solar installation that we have in our campus. Right now, we have around 2 megawatt of solar PV installation in our campus. So a significant part of the demand comes from solar, and the plan is to increase it further. Now these 4 components, SCADA, AMI, home automation, and solar PV, these are seamlessly integrated into a system integration platform. Okay, so when I say seamlessly integrated, on paper or on words, it looks or sounds very nice, but it's not a very easy task. These 4 subsystems are entered. So these 4 subsystems are entirely different in property, their characteristics. Okay, and integrating these 4 systems is never a very easy task. Okay, so that is something we had to do in our control center, and we will very shortly speak a little bit of details about these subsystems. Okay. And as I mentioned, this platform is working as a training and demonstration facility for utilities, industries, and academic institutes. Okay. About the electrical system that is we are dealing with, we in IIT Kanpur we receive power at its 33 by 11 kV substation. That's our main substation. And then we have 10 number of, in fact now it's 11 number of 11 kV by 415 volt substations. Okay, and the entire distribution system 11 kV network is underground now. Okay, we have cable distribution system. So all these substations, 11 plus 1, 12 now. So 12 substations, we have RTUs installed, remote terminal unit, and all these substations, they are included under SCADA now. Okay. And in the process, many of the substations were upgraded. Some of the devices, some of the breakers which were not communicable earlier, they were made communicable either through retrofitting or through replacement. Okay, so wherever retrofitting was possible, we did that. Otherwise, we had to replace the equipment. So our entire distribution system now is controllable. Monitoring, control, and protection is possible through SCADA. Okay. For the SCADA coverage. So this is a very unique scenario, not unique in the sense, which is rare scenario, at least in the Indian context. Very few distribution systems in India, they are actually entirely observed by SCADA at this point. I know in Calcutta, CESC is having SCADA, very good coverage. Tata Power is also having. Therefore, in selected places, we have full-scale observability of the distribution network with SCADA. Okay, in many places this is a problem. Okay, you do not have a full observability with SCADA in the distribution system. Okay, so that's about the SCADA scope, and then we also have solar PV, rooftop solar PV. Each is having 5 kilowatt peak rating. So this is installed on the rooftop of 19 houses plus one control center. Okay, and these 20 installations, this is something unique that we did. We went inside these houses. Okay, we had set up home automation system. Okay, home automation system, as well as we had installed smart meters in those 20 installations. Not only 20, now we have close to 50 installations which are monitored through smart meters. And our advanced metering infrastructure is scalable. It has a scope capability to accommodate up to 5,000 number of meters. Okay, so we have for this part of the system 20 installations with solar PV, home automation, AMI, and as well as the distribution transformer is up to distribution transformer 11 kV by 415 volt transformer. Outgoing 415 volt in the substation is also monitored under SCADA. Okay, so this is the electrical system that we have. Beyond that outgoing 415 volt, we have smart meters in selected places. Okay, so that's something which we need to keep in mind. Okay. These are the functionalities, basic functionalities that is implemented in these project. We had upgraded some of these houses to smart homes. We had requested the inmates, majority of them are faculty members. We requested them to offer their houses as the test beds for our project. In fact, my house was also one of them, and well, it's not actually a very easy thing. Retrofitting and carrying out these modification works for a existing house is not a very easy task. Okay, there is a lot of interference in the house, so we had to go through those processes. I will mention about that towards the end. What are the social challenges for these kind of activities? Okay. Then we had advanced metering infrastructure. Some of the substations had to be upgraded to smart city or smart substations. We had a full-fledged control center, smart city control center. We are working on renewable integration, PV. We are integrating, and the moment you have that kind of monitoring mechanisms, SCADA, AMI. By the way, you also have phasor measurement units. I think we have now 6 PMUs installed in the campus. Mostly they are being used for research purpose. So we have a very good monitoring mechanism in place now, but issue here is that you have to have a mechanism to store and manage the data. So you have to have a IT infrastructure. In fact, if you talk about the smart grid, it's nothing but a marriage of electrical system with communication system and information technology. Okay, so it's power plus communication plus IT what makes the grid smarter. Okay. So our system integration platform has enterprise service bus architecture included just to make sure that our system is modular and upgradable or scalable. Okay. And then we also had, I did not mention that 4 of these 20 installations have battery also. So they have battery storage. Okay. So you have to have a storage management system as well. So I'll talk about that shortly. So these are the basic functionalities which we included in these smart city project. This is the overall system architecture. I think I can use the pen. Let's see. Right. So let's use the pen maybe. Okay. So we have this SCADA server, right? And RTUs are installed in all the substations. And fortunately, we have a very well-laid Ethernet architecture, Ethernet system, well-laid structure in our communication system in our campus. So we exploited the existing communication system. Okay, but you may argue that just because IIT Kanpur has a very good communication network, you had used it. But what about systems implemented outside? Okay, we did address that as well. In fact, there was a directive from the ministry that we do try different communication mediums. So we had gone for wireless communication. In fact, within the houses, we tried Wi-Fi, Zigbee, Z-Wave, RF communication technology. So different communication technologies were used. Okay. And one thing you might have noticed, this is our this shows our AMI servers. So communication is a prerequisite for this kind of setup. If you have noticed already, right from the substation, starting from the substation into the into the premises in the residences, we have to have a very well-laid communication infrastructure. Okay, so that is one prerequisite for these kind of activities. Communication is a must. Okay. So this is the overall architecture that we have in our campus. Next, let's move on to the individual functionalities that we have. These are the standard features for SCADA. By the way, one thing I'd like to mention here, just because it is a project carried out by an academic institute, we did not use any ad hoc technology here. Whatever was done in this project were according to industry standards. Okay, so our SCADA, AMI, home automation, solar PV, everything followed industry standards. So why did we do that? Because see, the very key idea was that we are proving a technology here or demonstrating a technology here. If it is successful, this can be replicated outside. So that was the key idea. So we could not use any ad hoc or unprepared technology here, okay, or something we just immediately use it. No, we had to go for standard technologies which are available in the Indian market. Okay, in fact, our SCADA vendor was an Indian vendor. The SCADA system was indigenously developed. So these are the standard features for SCADA. We have a very control and protection mechanism which are offered by any standard SCADA. So these are the, let's have a look at the architecture. This is something I was referring to. We're using IEC 104 protocol for SCADA communication. This is the RTU that is, in fact, our SCADA vendor was an Indian named Synergy. Okay, it's a homegrown, completely Indian manufacturer for SCADA. So Husky is the trade name for their RTU, and RTU was connected to a number of multifunction transducers. Transducers were sensing the voltage, current, power factor, etc., and also the status of breaker. through Modbus, those were communicated to the RTU, and from RTU, these are over the Ethernet network that was communicated to the control center. And this, if you look here, these are the standard protocols being used at different levels. Okay, these are industry standard. If you go outside and look into a standard SCADA installation in any utility, you'll find the same protocols. Okay, so our system can be easily replicated outside. All right. So that was one of the key ideas. By the way, you see this GPS clock here. All the RTUs, those right now we have 12 RTUs are GPS synchronized. Okay, so the measurements that you have from the RTUs, they have a timestamp, and every few seconds or milliseconds, these RTUs are synchronized. All right, through internet network time protocol. This is a picture of our control center. We have the entire, this is our single line diagram of the distribution system. Two of the workers here. These are some homegrown, we are doing some developments in the lab as well. And some analytics which are displayed over here. Weather conditions, solar PV forecast, what are the current solar generation, what is the status of your daily load consumption, those kind of information, they can be brought into the control room, and we can have a look here. And let's have a view of the single line diagram of the entire SCADA system. Just 1 second. So this is the single line diagram, and you can actually zoom into any substation, and you can in real time you can monitor what are the flows, voltage levels, etc. Okay, and you can control as well. And there are many finite details which are possible to have through this SCADA system. You can see the train historical data. Why historical data is important? Suppose somebody wants to work on load forecasting. Okay, so that time this historical data might be important to him or her. Okay, so these kind of information are easily available at our control center. Some more information. This is individual substation view. Okay, now one thing I'd like to mention here, this entire SCADA platform, including their SCADA software, etc., was delivered by the vendor, SCADA vendor. So you might wonder what is our role here. Okay, so see, during the tendering stage itself, we had made sure that we can integrate our algorithms into the software or the platform that is provided by the vendors. Okay, so now we are working on applications. We will talk about these shortly. We have applications like set estimation, fault location, network reconfiguration. Those applications we are working on, and those algorithms actually do not come with this SCADA. So SCADA provides just a basic platform. It's an API kind of thing, Okay, so we write our applications, and we had made sure that we can port our applications or integrate our applications into the platform that is provided by the vendor. So that's where our research aspect comes in. Okay, so this is just a tool for us. Using this platform, we can validate and test our algorithms, whatever we are working on. Okay, so that was very important, and this is where exactly this particular project was different from the other smart city pilots which were executed in India. Okay, we were the only academic institute, and we had made sure that these kind of activities we can do with this system. All right. So any questions so far regarding this SCADA installation? let's keep talking, otherwise things will, people may start sleeping.
Yes, actually the SCADA, which makes SCADA and any energy metering, centralized energy metering system, whether it is implemented in IIT Kanpur, because energy is also important na, for monitoring.
Yeah, you're talking about residential energy consumption?
And overall, suppose in the complex, suppose this is a holistically, that is suppose IIT Kanpur, holistically there is residential and administrative building, a lot of laboratories. So individual section wise, some energy meter I hope there will be there, and from that
So
individual energy meter there will be centralized. I hope you got.
Stations, whenever you have an RTU, the RTU will measure in both the instantaneous power and cumulative energy. Okay, so all this information you can get from the RTU. Okay, so that comes to the control center. Not only energy, frequency, power quality parameters, what was the power quality, power factor, everything you get at the control center for all the substations. So SCADA gives you everything, individual flows in the lines, what is the power flow, okay, what are the voltage, current, etc., power factor, up to 415 volt outgoing lines in the 11 kV substations. So that kind of information we have in the control center. Okay. And beyond 415 volt, yeah.
Everything will be real time is available. Real time, the it will be available.
Yeah. I mean, see, the way it works, RTU polls the transducers every 2 to 3 seconds. Okay, so every 2 to 3 seconds, this data are polled by the RTU and they are communicated to the control center with along with the timestamp.
Okay. One more thing, that SCADA system was supplied by which, either Siemens or probably substation or
by Indian vendor Synergy.
Sir, pardon? One second.
Synergy Systems.
Okay. Not Siemens. No,
it was an Indian vendor. As far as possible, we went for Indian vendors.
Okay. Thank you, sir. Thank you for your information. Great sharing.
So let's move on. Our next subsystem is advanced metering infrastructure. So here the main components, of course, would be smart meters, the associated communication infrastructure, and the data management system, that is your IT infrastructure. Okay. So when we started installing these the system, we had IS 16444 Indian standard for smart meters, but unfortunately none of the smart meter vendors could give us certified meters. Okay, so all they could provide us was a some kind of declarance that their meters conform to those standards. Of course, we had tested those inside the campus, but what actually happened, there were at that time there were only, I think, 2 testing agencies in India. One was CPRI and the other one was ADA, and there was a long queue in those testing agencies. It was taking a long time. Anyway, so right now I think we do have tested meters, certified meters. So these meters they can do net metering. Suppose you are generating in your on your rooftop, so your generation would be subtracted, okay, from your total power that you are consuming, right? And you'll be metered. So that is net metering. These meters are tamper proof. Interestingly, this feature of smart meters we can see only in India or in these Asian countries. Okay, if you purchase a smart meter maybe in somewhere in maybe North America, somewhere in Europe, probably you do not have this feature. So this is interesting. I mean, tamper-proof meters they are needed only in our place. Okay. So anyway, and these meters have remote disconnect and connect features. Okay, and they have this GSM, Wi-Fi, or Ethernet connectivity. and you have a smart meter network. See, usually the way it works, the smart meter communicates the data to the data concentrating units, which are DCUs we call, and from DCUs through Ethernet network, they are communicated to the control center. Okay, and in the control center we have servers for this MDMA stands for meter data management system. So we have an IT infrastructure to manage these data. Okay, so we have servers for SCADA, servers for smart meters. Okay, in fact, in our control room we do have a server room as well. Okay, so this is the overall AMI infrastructure that was implemented. As I mentioned, right now these 20 installations, as well as all the student hostels, major academic buildings, are under AMI now. The plan is to, as soon as as and when the funds are available, we will replace the conventional meters with smart meters in throughout the campus. Okay, so that's the situation with the AMI implementation now. All right. And from these smart meters, just to give an idea of what kind of data we have, the smart meters typically, if you see in any utilities outside, I'm not sure in Durgapur if it is already started. Kanpur, I see in many places when we move around outside the campus, we do see the smart meters which are installed or placed on the walls outside houses. Okay, so I'm not sure if that is the case in Durgapur. So these smart meters typically they are polled every 10 to 15 minutes, typically 15 minutes in utilities. Okay, so every 15 minutes you get the data from the smart meter, and there are basically two types of data that you get from the smart meter. One we call instantaneous parameter, and the other one we call load parameter. What are those things? Instantaneous parameters are the only instantaneous, not instantaneous, RMS power, power value, reactive power, real power, uh, then any power quality parameter. Okay, those things we call instantaneous parameters. They are polled every, or they are sent every 15 minutes. In our campus we are doing it every 5 minutes because we can afford to do that. So this data are sent, and along with that, every once a day or twice a day you get the cumulative information. Suppose I have a smart meter in my house, so I'll be sending, my smart meter will be sending these instantaneous parameters like power, real power, power quality, etc. every 5 minutes in our campus. And at the end of the day, it will also send how much kilowatt hour I have consumed. Okay, there is energy information is also sent. So that is something we call load data, load parameter. So these two information we get from the smart meters. So now already we have noticed that from SCADA, I have mentioned we get data every 2 to 3 seconds. Now from smart meters, we get data every few minutes or 5 minutes, maybe 5 minutes, 10 minutes. Okay, their protocols are entirely different. Okay, SCADA we are getting from 104. Smart meters, usually we use DLMS protocol. Protocols are different, time stampings are different. Okay, so mainly they're communicated through GSM, so they might get a timestamp there. So their refresh rates are different, so they're entirely different type of data. Okay, so it's not easy to combine these two things. Of course, this is something we are trying to do now as a research activity. Okay, so let's move on to the renewable or solar PV system that we have. This is a typical setup that we have. See, we have two types of setup here. As we mentioned, 4 houses have battery backup. Okay, and remaining 16 installations, they are simply connected to the solar. And as you know, if the battery is not there, solar inverter will not work if the grid is not there. Okay, so for these 16 installations, we call the inverters grid tie inverter. So this is the grid tie inverter, and if the solar, if the power goes away, goes off, then this inverter stops working. So you might wonder what is the utility of solar then if the power is not there, solar is also not working. Okay, unfortunately that is the scenario in majority of the setups across India and across all over the world actually. Okay, so we do have this grid, we call it grid following converters most of the cases. The problem is if the power is not there, then they don't get a reference voltage or frequency. Okay, so that's the kind of problem we have. So we call them grid tie inverter. Okay, and the setup is such that if there is a consumption load within the house, that will be served first of all, and if there is anything extra out of the solar generation, that will be pumped to the distribution system. Okay, so first of all, loads inside the house are met, then remaining or extra amount is pumped to the grid. So that's the kind of setup we have. All right, and this is a typical one of the houses we have shown here. This is not my house. It is not very. My house is not so well kept. Okay, so this is one of the houses in the campus where we have these solar PV installation. Okay, so four of the houses. By the way, four of these houses they do have battery. So there we had the so-called hybrid inverter. Those inverters. In fact, my house is also one of those. My backyard is now almost like a lab. So these houses they can work off grid as well. So these inverters they are connected to battery, they are connected to solar as well as grid. Okay, so even if the grid is not there, these houses can work. Solar can work. All right. So by the way, they at the time when we are doing this installation, these hybrid inverters were not very common in the Indian market. So we had to go to the customer and to the vendor's place, had to do a lot of modifications, testing, etc. But now I think these are not so there. We can have a hybrid inverter in the okay. There are many vendors for that, but it was not there at that point 2 years back. So moving on, our next any questions so far?
Sir, I have a question. That grid tie inverter, which make and it is available in India? That is a new technology or previously it
No,
was
now
there?
now this technology is available. This was supplied by an Indian vendor called L Componix, and this particular inverter was brought from China. Okay, of course now
Okay,
we have
okay.
stopped buying anything from China.
Yes,
But
yes, that's so. Any other from UK, USA, any well
yeah,
developed countries are
many
supplying?
vendors. You have from SMA, you have from I think Siemens also has. There are many vendors
Okay.
now. Okay.
And
Statcom
one more
there.
question, sir. I have that accuracy level of that smart meter class. Which class accuracy level exactly? You are
Mm,
in your yes.
yeah, you do you see the picture here? Which one you are? Oh, this one, single phase smart meter.
Yes, sir.
Uh,
Yes, sir. That,
you have to check that. I cannot tell you definitely what this was manufactured. This
okay.
was from Sumeru Vade. So you can check their specifications. Data sheets probably are available online. Sumeru Vade is one of the well-known meter manufacturers. Okay, in India.
Okay, sir. Okay. Okay, sir. Okay. Thank.
Okay, so let's move on. Now we are into home automation, our fourth component. So here we had gone inside the houses. So within the houses, the setup is like this. We have near the distribution box, we have a tab, the usual tablet PCs that you have, and we have controllable switches. Okay, controllable wirelessly controllable switches uh, in the switchboards. In fact, conventional switchboards are made controllable with the help of a module in series. Okay, so that was the modification that we had to do. So after that, your fans, lights, etc. can be controlled, but that is something which we do not essentially would like to control, but then that's why we call them non-essential essential loads. Okay, we have another category of loads which are typically connected to 15 ampere plugs, like your air conditioners, geysers, okay, big refrigerators, etc. So these load we call non-essential. So why non-essential? Non-essential in the sense, just imagine if somebody switches off your AC for 5 minutes, or switch off your uh, geyser for 5 minutes. It does not cause a huge discomfort. Okay, probably you don't worry about it too much. Okay, but suppose you are working or studying and somebody switches off your fans or lights, it causes irritation. Okay, isn't it? So these fans, lights, we are calling essential loads, and geyser, air conditioner, etc., we are calling non-essential. Non-essential in the sense they are essential, but we can afford to keep them off for a short duration. Okay, so that's the idea. And then we are playing with these non-essential loads. We are controlling them. Why at all we are controlling them? We are implementing the so-called demand response. Okay, I'm sure many of you must be knowing already what is a demand response program. Just one quick example. Let's say the utility or the maybe the demand is high. Okay, it's maybe say 2 o'clock or 3 o'clock in the afternoon. It's a summer time. People are using their air conditioners heavily, so the load is very high. Overall load in the distribution system is very high. Now what happens in the differential pricing mechanism? If your load is high, you might have to pay more, isn't it? And this is true for the utility as well as for the individual consumers. Okay, as a household owner also, you may have to pay more if you are consuming more during the peak demand period. So it makes sense that if you can reduce your load during the peak demand period to some extent. Okay, so in that case you will be the gainer, utility also will be the gainer. So it's a win-win situation, right? So that's something called demand response, in which we can reduce the peak demand, or if there is a low demand period, we can try to shift some of the non-essential loads during that period. For example, if there is a peak demand period 2 p.m. in the afternoon, it's a very hot summer afternoon, and suddenly you decide to wash your clothes in the washing machine. Okay, so there is probably not much harm if you do it in the morning hours or evening hours when there is a low demand period. Okay, so we can shift the loads. That's what something we call valley filling. Okay, so this peak load saving and valley filling kind of mechanisms can be implemented, but for that the enabler is that you have to have a control over the load. That's the first prerequisite. Of course, you have to have a communication medium, but the first thing is that the load should be controllable, and this enabling the loads or controlling the loads through Wi-Fi switches, the purpose is that we wanted to control the loads remotely as well as locally. So we took a declaration from the inmates whether we can control your loads. Okay, so this is how we can implement the demand response. Okay, but having said this, in fact, this is not only our experience worldwide, that demand response within the residences is not very successful. Nobody wants to allow somebody else to control their loads. Okay, it's some kind of intrusion in their privacy. You may think of look into it like that. Okay, so but in commercial or industrial setups, demand response has been okay. Of course, if you only control your loads, it may not create a huge impact on the utility, but let's say 1,000 of us, many people are doing this same activity, then it causes a significant impact on the utility operation. Okay, so demand response is a very useful thing that is rapidly coming up in the distribution operation. So this was probably the first setup that, at least in India, that we had tried this demand response thing. Okay, within a distribution system. And then finally we had integrated these all four components into a, in a modular way into the control center. Okay. And at every stage, as you mentioned, we had implemented enterprise service bus architecture. The software architecture was done in such a manner that we can fit in applications or software from different vendors. So in fact, that was another uh, important consideration in this setup. Okay. In fact, that should be one of the considerations for all such kind of setups. You cannot allow the system to be of proprietary nature. It has to be a modular and interoperable. In fact, nowadays you'll be hearing a lot about interoperability in the distribution system. Unfortunately, in the distribution system, interoperability is not existent so much. It is there in the transmission network. You can buy, for example, PMUs from different vendors. They can fit into your WideDM monitoring system. But unfortunately, in the distribution system, if you have smart meters from different vendors, and you're trying to integrate in your hidden system or into your control center, it's not an easy task always. So that's something which is continuously debated within, the vendors meets and all. So this is an issue as of now. This interoperability is an issue in the distribution system. Okay, so integration is not a very easy task, especially when you have equipment from different vendors. Anyway, coming back to our problem, so this is something which was we had to go through, as we mentioned in the beginning. Modifying an existing house is not a very easy task. We had to customize the distribution boxes within the houses. Okay, so I think we have a picture of the distribution box. This is the picture of the distribution box, and this is the overall structure of the architecture of the PV integration, solar PV integration. Okay, one part is non-essential and another part is essential. This is essential. In fact, in the distribution box, we have two rails. If you see, just 1 second now. So sorry about that. If you see, there are two rails here. One rail is for non-essential loads, other rail is for essential loads. Okay, and we have to replace and do this modification, and it actually created in some instances a lot of discomfort for the house inmates of the houses. Just imagine 5-6 people roaming around in our house, changing the switchboards, etc., for half of the day, and they are coming back maybe again after a few days. So it's a field work, nothing is guaranteed, it may or may not work. So those kind of disturbances are there. So it's retrofitting an existing house is not a very easy task. So that's what we figured out. Okay. So this is the, let's move on to the next one. This is the overall system integration structure that we have. So now these online classes are going on. Anyway, so this is the one of the system integration dashboard that we have. Some homegrown developments are going on. Okay, along with the vendor provided solutions, our researchers are also working on different applications. These are some of the research activities that we are continuing or using this setup. For example, remote monitoring and control applications for smart homes. We can design different visualization techniques using the data that you receive from the control centers. Okay, and you can have this. We are also extensively working on the distribution set estimation algorithms. Okay, and we are trying something new here, which was not so much explored. We are trying to combine the data of smart meter and SCADA, which is, as I mentioned, is not a very easy task. Also, we are having those PMUs, so we are trying to combine the measurements from PMUs, which are giving data in milliseconds, SCADA, which is giving in seconds, and smart meters, which are coming in minutes. All three are having different protocols. Okay, it's not a very easy task, but why at all we are doing this? See, as I mentioned, beyond 415 volt outgoing line at the 11 kV substations, we do not have complete observability. Okay, so that on the other end of the line, if we have smart meters, we can have that information, and then we can have a complete observability of the system till the end of the 415 volt line. Okay, so that's something we are trying to establish. In fact, we are having a joint project with CESC also, and we are working on this particular aspect. Also, using this information, we are trying to find out the line or estimate the line parameters, distribution line parameters. Okay, we can, using the historical information, we can work on load forecasting. Okay, we can our breakers are controllable. We can work on distribution reconfiguration, and we can improve or reduce the losses, improve the voltage profile. Okay, many things you can do using this monitoring or control mechanism. We're working on fault detection, location, isolation algorithms. Okay, billing information system is another area where you can work on using the existing platform. As I mentioned, we are using this setup for validating our demand response mechanism. We are also having people working in power electronics areas who are working on solar PV converters. Okay, so there are various applications where the biggest advantage that the students are getting now is that they can validate their algorithms online in real scenario. Okay, so that's a very big advantage that they are having now. Some of a few snapshots of what was developed in-house. We have a dashboard which shows cumulative generations. I think this is a cumulative data. For individual houses also we have the data. You can note of course the figures are very small here. So this shows the generation for a particular day, I think. Okay, you can see where now one thing we have noticed here, we have 5 kilowatt peak installation, and during winter, if we, by the way, we have to clean these solar panels at least a week, once a week, and if it is cleaned immediately after that, the generation is very high. We have seen generation up to 4.5 kilowatt. Okay, summertime, what happens, the temperature in Kanpur, it goes to 45-46 degrees, and efficiency drops a little bit. Okay, the ideal condition is plenty of sunlight and low temperature. Okay, so that's the winter. Unfortunately, winter the sunlight's it's a bit less. Okay, so anyway, these are the observations that you can have if we're using this setup. And another thing we have mentioned, in case you have solar installation there, make sure it is clean, because our experience says especially in Kanpur, I'm sure in Durgapur also, because steel plants are nearby, dust particles accumulate on the panels, and efficiency reduces drastically. It almost goes to half. Okay, so it needs to be cleaned regularly. Also, it depends on how much inclination you have put your solar panels and so on. Okay, typically you put the solar panel at a angle which is equal to the latitude at that location, okay, so that you can have maximum cumulative amount of solar radiation throughout the year. So this is one using the Google Map. This is not particularly GIS, but the students have used Google Map and located the houses inside the campus where we have these installations, okay. And this is one picture of the home automation dashboard that we have. You can control individual light spans, etc. from the you can actually control the brightness also through the home automation system, okay. So I'll end here and take up any questions that you have.
Sir, any remote lab initiative in IIT Kanpur?
Pardon me?
Any remote lab, virtual lab. Suppose
What?
during pandemic situation, students are outside the in the
Okay.
institute.
Uh-huh. Virtual lab in the sense is not there, but we do carry out these workshops. In fact, as I mentioned, we have an MOU with the Ministry of Power, so twice a year we conduct workshops. And most probably the one that
Already,
to have in December would be
already
online.
okay. Already IIT KGP participated and
Your voice is dropping. Sorry.
yes, IIT KGP already taken action.
Oh, okay. I see. Okay. That's good. Yeah.
Thank you, sir.
Yeah.
Sir, I
Yeah.
have another question.
Yeah. Please.
Suppose
Yeah.
the load demand. Suppose
Mhm.
we are switch off this unnecessary loads, right? When the demand is higher.
Mm-hmm. Yeah.
Sir,
Please.
can you hear my question? During peak load duration,
Uh-huh.
the unnecessary loads may be switched off, right, sir?
Yes.
How we can unnecessary loads or necessary loads in hostels?
We do not in hostels.
Hostel students. Yeah,
Oh,
already you are
oh no.
estimated the
In
20
student
homes in
hostels,
some
we are not
hostels,
doing
right?
that. We are doing this in residences. Okay, not in
Oh,
student
okay.
hostels. Okay. Hostels, they mostly the load
Sometimes,
is essential.
sometimes the load is goes very high, but
Mm-hmm.
we can have only for 20 home automations, right? And also
Proof of the
10
concept.
substation.
So
Some 10
20 houses
substation
doesn't
need.
say huge impact, of course, but this is a proof of
Yes, sir.
concept. If you have these mechanism in large number of houses, then the impact will be significant.
Yes, sir. Right, sir. Okay, but the establishment cost maybe it goes very high when we
No,
are moving towards smart
no, it's
cities,
not very high. Okay.
because
Home
of we
automation
want
doesn't
to
take
install
much.
for SCADA, smart
SCADA is
meters.
expensive. Yes, SCADA is expensive, but SCADA is anyway it's a necessity,
Yes.
especially when you are having these renewable generations coming in. So slowly, I think SCADA will come into these distribution systems.
Okay, sir. Okay. Thank you, sir.
Thank you.
Dr. Chakravarti, good morning.
Mr. Roy,
Good morning.
morning.
How are you?
Good morning, sir. This is regarding regarding the app development. So you have developed in-house that app?
Yeah, some of the apps we are developing, the students, researchers, they are developing.
Okay. So this for home automation purpose, what type of app you have developed?
It's an Android-based app they are developing. In fact, see what happens with the home automation vendor. One default app comes in that is
Okay.
just to provide you some basic on-off control. Now, using that on top of that, we are developing another app through which you can implement some logic. That
So one is
what type the day you can switch it off or switch on. You take the reading from SCADA. In fact, this is where you have to integrate SCADA and EMI. From SCADA, the information comes in when is the or where is the peak load, and during that time you have to communicate with the individual appliances or individual house level that you can switch off your loads. Of course, this is voluntary, but the control is there.
But that on-off switch already that readily available. That say different companies are there, so that is Wi-Fi enabled that on-off switch. So
Right.
if we implement that one through that Blink software, that is one Blink software is there. So through that Blink software or that individual there itself having some apps. So what is the difference? Because you are having the total monitoring, and that monitoring the data can be also accessed through some software. So can you integrate that one to that in Excel? That the people
Yeah,
are
in
dealing
fact,
with the Excel also they are integrating.
In fact, this home automation, as of now, is a very immature area technology-wise. There is no robust solution. Not at many possibilities are there. So we are just implemented some proof of concept thing that it is possible to, and it is advantageous. But it is, as you correctly mentioned, there are many possibilities. Okay, it still needs to be mature.
Thank you.
It's true. Any other
Any other questions?
So how are things in Durgapur?
Sir, everything is right.
Uh-huh.
Everything is right.
The students are there.
No,
Things are
no. So that one is right now. The students are not allowed inside the campus. So within
okay.
short period, they will be called.
I see. Okay.
But they're doing their all activities from their home itself.
Okay. So classes are going on
Yes,
online.
online classes are going on, and we are
Okay.
taking regular classes using MS Team, because I am licensed version we have purchased.
Okay.
So we have control all those things using MS Team only.
Okay. Yeah, we are using Zoom for that.
Okay.
Sir, what about Sir Professor Singh? How is he?
Professor
Professor Singh.
Yeah, he's there. He has come back.
Wine Singh.
He's also.
No, SN Singh maybe in your department, sir. SN
Yes.
Singh, who was
Yes.
a vice chancellor of.
Yes. It's Gorakhpur MMUT. Yeah, he's there. He's good.
Okay, good.
Okay. So any other questions from the side part of
One more
participants?
question, sir. So one more question.
Okay.
The home automatic purpose they used for one is GPRS and another one is ZigBee. Why, sir? You can use for two different communication technology.
COAB also. So there was a directive from the ministry that you try different technologies. Then you do a comparative analysis. So that is
Which
ongoing
one
now.
is best? Which one give for
Suppose ZigBee and ZOAB, they are good.
okay. Thank you,
They
sir.
better. Huh? Okay.
So I think no other questions.
Okay, then thank you very much.
Thank you, sir, for your informative and nice presentation. Hope that all the participants will be benefited, and they can share your they can share their knowledge in their future growth also.
Sure.
So we
You
look
happen to
forward
visit
to having you
Kanpur?
on.
No, please try to visit Kanpur sometime. Well, look
Okay,
at
right.
what.
Okay. So from the thank you once again from the part of participants and
Thank you.
from the NIT Durgapur and AICT Training and Learning Academy. So you are requested to say few words before conclude the session, sir.
Oh, it was very nice, to be able to interact with faculty members and students from NIT Durgapur. It was my college, and I graduated in 97. and I'm sure a lot of things have changed, and things have changed for better now.
Right.
I think I went there in 2016. That was the last time I went there. I had a talk there. So, yeah, it was very nice to be able to talk to you, and wish you all very best. And please stay safe and careful in this
Right.
pandemic situation. Okay. Good. Okay. So thanks.
Thank you, sir. Thank you.
Thank you.
So can I take one photograph with you? So Biman,
Audio.
Aniruddha, Ashish, are you there? Are you here?
Yes, sir. Yes, sir.
Please switch on your camera. So, sir, this is Dr. Ashish Kumar Bhure, so convener of this faculty development program. Ashish?
Yes. Good morning, sir.
Good morning, all of you.
How are you, sir? Fine.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you. Sir. I'll in touch with you, sir.
Okay, yeah, sure. Thanks. Bye.
Thank you. Thank you. All participants are requested to give their session attendance. I am sharing within 1 minute. So I have shared the session attendance link. All are requested to submit the same at the earliest. And that link will not be shared in second session. So all are advised to fill the form this session only. No further request will be entertained. So all are requested to submit session one attendance using this link only. And that link will not be active in session 2. It will be automatically deactivated.